I'm going to show you how to find a critical value. And we're going to need the critical value later on in the lesson to actually do margin of errors, which comes next. So, first thing you need to know is a critical value is a right-hand z-score. And remember, z-scores come from normal curves. So what we're going to do is we're going to be given a confidence level. Such in this first part, we're given the confidence level of 86%. And what that means is when we bound this particular normal curve, inside of here is where our plausible value is going to fall. We want 86% of those values to be inside of here, like this. And we want to find the right-hand z-score that corresponds to 86%. So we call that a critical value or ZStar. So I'm trying to find that value there. Now, if I want to find the area inside of a normal curve, I already know how to do that. We did that with percentiles. We actually used the inverse norm function. So we're going to use the inverse norm function here to do this. But here's what you need to know. Remember, a percentile measures up to a particular value. So we're going to measure up to the z-score and everything below it. So if I want 86%, here's how this works. Inside of here is 86%. But if I want to measure up to this value, I also have this little bit out here. And this little bit out here is the same amount out here. Well, if this is a normal curve, it is symmetric. And what that means is that if there's 86% on the inside, that means that there's 14% on the outside because it has to add up to 100%. So if there's 14% on the outside, that means that there is 7% here and 7% here because we cut the 14 in half. Now, I'm only interested up to this right-hand z-score, so up to and everything below because I'm measuring a percentile. So I'm measuring everything back this way. So what that really means now is that instead of just being 86%, I have 86% plus 7%. And so to calculate the critical value z-star for this, I'm going to use the inverse norm function. And I'm going to add 86 and this 7% on here, and I get 0.93. So when I go to my calculator, come over here, and we're going to find the z-score. And the z-score is the inverse norm, so we go second, vars, number 3, inverse norm. And here, for inverse norm, I'm going to type in 0.93. The mean of a z-score is always, the mean of a z-curve, and what you're measuring on a z-curve, is always 0, standard deviation 1. And we're going to leave this at left. And we'll go to paste. And if you don't see this left, center, or right, you don't need that. Just worry about the mean 0, standard deviation 1. Or if you don't have any of that, you have to type it in like that. Type it in like this. If you press enter. The z-score that corresponds to this is 1.476. And so really what this means is that in between the values of 1.476 on the right-hand side and it's symmetric, so this is negative 1.476 on this side, lies 86% of the values. And we can check this. I could literally go back and find the area inside of this curve right here and make sure that verify that it's 86% by using the normal CDF. Now I can go back and find the area underneath the curve using normal CDF. If I press second, I'm just going to verify this, by the way. Vars. So second, vars, normal CDF, which is number 2. The lower bound here would be negative 1.467 or 476. And the upper bound here is positive 1.476. Mean 0, standard deviation 1, because we're still talking about normal scores or z-scores. When I paste this in, if you notice here, look at the area. The area is set at 86%. So those are the right z-scores that we're looking for. And we're only interested in, though, this right-hand z-score. So this is what we're going to call z-star. That is what we call a critical value. So if we look at 90%, for 90%, on the inside of the data, on the inside of the curve, is 90% of the values sitting here. And these are the plausible values. Well, if there's 90% on the inside, how much sits on the outside? Well, 10% on the outside, but it's 10% split amongst two sides. So this is 5% here and 5% here. And so again, I'm calculating up to this right-hand z-score over here, up to this right-hand. So this is going to be my z-star. And so when I calculate everything up to and below that, I see that I have to do 90% plus an additional 5%. So this would be inverse norm 0.95. And so when we do this in the calculator again, we go second vars inverse norm, because you're calculating the z-score from the actual area given. So number 3, 0.95. Mean is 0, standard deviation 1. Leave it on the left and we'll paste this in. And we get a z value of 1.645. So for this last one, 98%, on the inside again is 98%. Which means how much is on the outside? There's 2% on the outside, but that 2% is split on both sides. So you have 1% here and 1% here. We're calculating everything up to and below this right-hand z-score. So we'll call that z-star. Everything back this way we want to calculate. So we see that is 98 plus 1%, which is 0.99. So we'll do inverse norm 0.99. And so in the calculator again, I go second vars number 3 inverse norm, and I get 0.99. Leave the mean at 0, standard deviation at 1. We're in the left tail still. Paste this, and I get a value of z star equal to 2.326. Now, here's what I want you to notice also. Notice that as your confidence level has increased. So when we were at 86%, the z-star that we got was 1.476, right? And when we were at 90%, the z-star we got was 1.645. And then when we were at 98%, the z-star that we got was 2.326. So what's happening as that confidence level is increasing? Well, that critical value is getting bigger. So keep that in mind as we move to margin of error, because that's going to affect our margin of error. So as the confidence level increases, the critical value also increases.